Hello everyone, welcome to this session. So in this session, we will continue the last one, write objective functions. In this session, we will write the binary cross-entropy function. So what is binary cross-entropy? This is also a function to calculate the error between a predicted probability and the true probability. So binary cross-entropy is often used as a loss function in machine learning when predicting probabilities for one item belongs to one of the two categories. So that's why where the binary comes from. So the formula is here. So we can see the yi is the i's true identity of y. So we also call it label is 0 or 1 because it's binary, right? So the y with a hat, this is the predicted probability of y, is y. So we can see this is a definition. And when there are data items that there are more than two categories, not 0 and 1, but 3 or 4 categories, in this case, we need to use a categorical cross-entropy. So this will be covered in the third course of this specialization. So let's draw the binary cross-entropy to see what happens. So here I have two labels. One label is 0, one label is 1. Okay. So consider that the label is 0. So when the prediction is 0, then the loss is 0, right? So then when the prediction goes, and it becomes growing, and y is 1, we can see this loss is very big, right? Very large. And vice versa, so if the label is 1, so at 0, the loss is very large, right? So this is, at these 2 points, we can see they are asymptotic, right, at 0 and 1. So now we can program this function first, and then I will show the result, right? So you can program yourself. To program it, remember that we can use a vector programming in MATLAB to avoid using the for loop. And we can also make use of the MATLAB built-in functions to calculate the average. So you can try yourself to write this function as simple as possible. Later, I will show the result. So you can pause the video to do that. So here I'm showing you the answer. So this is a function, the binary cross-entropy function. So you can see the labels and the predicts. So those ones are, all of them are vectors. So that's why I use a dot multiply, and at last I use the mean, right? The built-in function. So we can write this function in one line. And we can also write it in an anonymous form, right? So like the last one, and you can try it yourself. So let's give an example about the binary cross-entropy. So now we are classifying animal images. There are two categories. There is a horse when the label is 0, or there is a dog when the label is 1, right? So there are two machine learning models. So one of them found for a picture of a dog, one of them predicts the probabilities that the image contains a dog is 0.5, while the other is 0.95. So this clearly shows that the second machine learning model is more accurate, right? Now we can quantify the accuracy through the loss function of the binary cross-entropy. So we just see the label is 1 because it's a dog, label is 1, and we put the two probabilities here. Then we call this function. We can say binary cross-entropy P1, let's use this 0.5 in, and the label is 1, so the loss is 0.69. And then we can put the P2 in, 0.95. We can see the loss is very small, right? So this is the binary cross-entropy. So more details, you can look at the live script. So that's all for this session. Thank you for joining. Bye-bye.